How are we doing? I think we might be live. I think we're live. Ready to start up another stream, working on mostly continuing this computer vision tracking camera robot stuff. Having a little bit better luck with it, knock on wood. I've also got a nice package to open actually from Bill of ATMakers. Sent me some good stuff. And Tuco is here with a bolt, really wanting to play. So here's the camera right now. It's currently really interested in that power pole. Oh, why is my desk camera not working? There we go. Hey, Tuco. Tuco really wants to play fetch. Alright. So I'll get into a little more on this later, but wanted to go ahead and mention this stream that we just scheduled. So this is going to happen tomorrow. Hey, Tuco. So this is the first time I've tried doing like a multi-person stream, so I think we managed to have a successful tech test today, and the streaming itself seems like it'll work out alright, but we're going to try doing Google Hangouts on air to stream to YouTube. So unfortunately it'll be YouTube only at the moment. Might experiment with other setups that have the output going through my setup where I can easily broadcast it to both YouTube and Twitch, but right now we're going to try the Google Hangout so that we can both have low latency as we're streaming. But I'll still be streaming my end from the video switcher rig, so I'll still have all the cameras and stuff here. Oh, Steven noticed that the, I assume that's the Twitch stream auto-playing? I think Twitch does that. So yeah, the plan is that tomorrow, this is, what does it say? So it's 11 o'clock a.m. in my time zone, or so that's Pacific time on the U.S. West Coast, 11 a.m. But it'll also be 2 p.m. Where Bill is on the East Coast, and you know, other time zones extrapolate from that. And there should be an archive afterwards. I think we have it set up for that. But anyway, the actual content of this, so Bill, if you don't know, he runs an organization called ATMakers. AT in this case is assistive technology. So specifically, it's like technology to help people with mobility or communication, you know, for specific degenerative conditions, or just for people who need a little bit of help with some technology to move around or to communicate with people. And there are a lot of different kinds of conditions that these bits of technology can help with, and it ranges from like stuff to control electric wheelchairs, to stuff to control like speech synthesizers or just computer interfaces, and then the input devices range from, you know, different sorts of buttons or keypads to like eye controls, to like, you know, mouth operated controls. And in this case, we're looking into a particular device that's like a keypad. So it seems to be just like a big membrane keyboard, but with a lot of features that are specific to like using this thing in an assistive context to control an entire computer interface. And it's this device that's still pretty massively popular among people who need it, but it's been discontinued by the manufacturer, and the drivers no longer work with Windows 10. So the manufacturer was actually nice enough to open source the code that they have for it. So I think that includes Windows 2000 drivers and firmware. And so Bill's looked at it a little bit, and he says it's like a Cypress, like an easy USB chip. So, I mean, I'm pretty familiar with those. It's like an 8051 with a couple of kilobytes of memory, I think. And so there's some question as to whether it includes like enough EEPROM space to just flash it with some firmware that has better features, or whether it includes any firmware storage at all. Because it would be optimal to just replace the firmware with something that doesn't need Windows drivers, and you can just use it as a HID device and use like a USB storage or a serial port interface to configure it. Like that would be great. Ideally USB storage or like web USB, so that you can configure it without having to install any new software, so that it's really easy to use. You know, kind of like MicroPython style, where you just plug it in and it shows up as a drive. So, and I mean, I know doing a USB storage on that particular chip is kind of pushing the low memory that it has, but I think if it was a very specific file system that was just for configuration, you might be able to get away with that. So, yeah, anyway, that's like kind of where we're going with it. So we're going to be trying to do that together tomorrow morning. Well, morning for me, afternoon for him. So, oh, that's interesting. Stephen, I just saw his comment that the autoplay was actually YouTube. I didn't know YouTube did that too. Speaking of YouTube, over on YouTube, Jemmy Hendricks says, ciao. Ciao. Oh, man. Well, I think the first thing I actually wanted to get into was opening this package from Bill, but I just wanted to announce when the stream is happening. I'm also watching the tracking here. I made a bunch of changes to the tracking between last stream and this stream. The last stream ended in a bunch of frustration because I couldn't even get the plugin to compile. I was having a bunch of stupid problems. So I had this secondary build directory with this problem that I'd never seen and was kind of inexplicable. And I never really managed to get to the bottom of that. I just rebooted, and then my original build directory started working again. And so, I don't know, I managed to get on with things, and I implemented some more changes to the image grabber, which is the component in the OBS plugin, which uses the GPU to give me a scaled down image at a particular resolution corresponding to whatever the computer vision software wants. And so previously we were running one of those to give us the input blob for the neural network that does object detection. And I was using that exact same image as input for the tracker. And I had a hypothesis at the time that the resolution was a lot of what was causing the tracker to be too slow to use. And I think since then I've realized that it's a combination of factors, and I don't even know if the resolution was necessarily the biggest problem at the time. But I did the refactoring, and now I've got two of those, and you can configure them separately. So I had it doing two separate rescales, so it would take... And the way this works is there's this... I've had to dive deeper into how the actual rendering pipeline works in OBS Studio, which is this broadcasting software that I'm writing a plugin for. And, you know, actually I'm realizing that I'm ranting on about the exposition, and still very high on my to-do list is get a cup of tea so that my throat doesn't dry out and implode. So let me do that, hold that thought, and then I'll explain the tracker and the OBS plugin. Tigeriest I guess I walked by and distracted it from the utility pole. It's very distractible when it's not tracking a particular object. That's actually one of the things on my to-do list to fix. Right now there are a couple of conditions that can trigger it to reset the object tracker. And I thought that would be useful, but actually I don't think it has been, and I think I'm just going to delete that code. So that unless there's a manual input or some other like computer vision object detection or some other control loop thing that tells it to do a particular thing, then I don't want it to reset the tracker. Right now it resets the tracker if the quality is below a particular threshold or if the area is below a particular threshold. And so it could just be that right now, some of those cases, the tracker itself is returning like not a number or something. And I guess this will tell me whether those are persistent problems or whether they go away after a frame or two. Yeah. This controller keeps going to sleep, and that's often why this fails to do what I want. Where's Tuco? I think Tuco's in the kitchen eating. I have the gains set really slow right now. That is very high on my list of things to do, is change how the gains work so that I can make the tracker more responsive. It sounds like Tuco's using the litter box. Oh, there he is. You can watch Tuco taking a dump. So yeah, I've got some tea, which is now probably too hot to drink. And I was trying to explain how this all works in OBS. Brr. Why did I just say... I have this habit, I've noticed I do this, I just say brr when the temperature is incorrect. It's like my temperature is incorrect error, not my this is too cold error. I'm happy that this tracker seems to be effective at the cat butt, even when it's... So yeah, I think... I was still trying to explain all the changes I made between the last stream and this one to improve the tracker performance. But I think most of it boils down to giving it a higher quality input image and turning off the scale detector so that I can use more of the CPU for position detection. Because from looking at the profile and from just playing with different options, the algorithm has two parts. It first tries to figure out where the image has moved in the XY, and then it tries to figure out how much it zooms. And that zooming part relies really heavily on this FFT implementation that seems to be somewhat slow. And so there are a couple of routes to fix that. Like if I can make the FFT faster, and it seemed like there are a couple of additional FFT libraries that it supports that I haven't quite gotten it to build with. And so one route that we could experiment with is trying to get it to compile with something like, there's one that it supports called Intel Math Kernel Library, or MKL. And there's a bunch of support for that in the build system. But as far as I can tell, the Windows build system support is present but not actually useful. Like it seems like it never actually sets the include file paths correctly, and then it fails to actually detect the library. So that might be another case to like patch OBS to fix that. Or sorry, this isn't OBS anymore, is it? This is dlib. Oh, now we're hitting the lower limit of where the camera could go. So if we had the winch movement in place, it would have been trying to back up the winch just then. So it would have tried to keep tracking him. Now he's over here, and I need to manually swing it over. Oh, that's the limit. Oh, Tuco has a very, very specific litter box routine, actually. He's a very tidy cat. Oh, these gains are so slow. Oh man, the object detector likes cat butt. Oh, this is so good. Hey, Tuke, you want to hang out up here? Vavasaur says, are you just using the FFT for correlation or other things? So the FFT is part of the correlation tracker algorithm. So, like, that's not my code, that's the code, I'm talking about the code inside dlib correlation tracker. This is from earlier when I observed that the correlation tracker was slow and tried to figure out why it was slow. And, yeah, and so I could get it down to, with useful parameters, maybe like 30 or 40 milliseconds with the scale detection, but without the scale detection, it's like more like 10 to 15 milliseconds, which is more like a usable speed. Because I would like to be able to get a timely result for every single video frame, and this is 30 frames a second. Hey, Duke. Tuco, you just so want to play. Hey, Tuke. Can I get you to play on the chair? You're like, no. Yeah. All right. Oh yeah, and then I've got this printed out. So I have this subsystem that tries to collect images for the computer vision, and I think part of the problem was that I was getting some ridiculous moire because of the low quality downsampling. And my first cut at it was just using the default rendering that OBS had picked out for that particular source. So that's not necessarily optimal because that can depend on the settings in the OBS UI, whereas actually the computer vision probably always wants pretty high quality downsampling regardless of what you've picked in the UI. So the closest thing OBS had built in is, so it has a bunch of different shaders that it uses for doing different sorts of upsampling, downsampling, color space conversion. And it has a single special downsampling shader that it uses for downsampling to less than 50% size. And that one, instead of the usual one bilinear sample that you get per pixel, it would take 9 samples in the shader and then average them. I think with some kind of weighted kernel. And so that's closer to what I want, although it's still not quite the sort of high quality scaling that I would ultimately like to have for the input to a computer vision algorithm, where it's going to be very sensitive to any kind of irregularities as the image moves around. Mikey is asking for the millionth time if I want to detect when Tuco leaves the scene. Sorry. I don't mean to be snarky. I just feel like people keep asking the same questions. It's okay though. I don't mind answering questions. I just have trouble with people sometimes, but it's not any of your fault. So the part of the reason it's not able to track Tuco right now is that it's not able to back up, which it will be able to once I have it on the winches. But yeah, if Tuco does leave the scene completely, we certainly have the option to have some kind of other algorithm that kicks in just to randomly look for him, or using an overhead thermal camera. I mean, and pretty much every stream someone suggests an IR collar, but I don't want him to just have to wear a collar all the time. So there's a bunch of options that we could employ. So far, my main goal is to have this thing achieve a useful balance of autonomy and being fun to control when there's humans present. And so I think, something like this where there's usually people watching it, I would rather prioritize having the ability for people on the other end of the stream to control the robot when Tuco is missing, rather than to just have it automatically wander. So like, I'm aware that that would be a cool thing to do, but it's not as interesting to me as increasing the interactivity, actually. Cat. Yeah, cool. Okay, well, maybe let's open this package, and then we can do some filtering tests. And I can gradually explain more about how this OBS filter works. We actually have this thing that's part of this Tuco Flyer project, that here is the Flyer camera filter. And so this connects to a server written in Rust, and it does the computer vision, and it also draws this overlay. And the information for both of those goes back and forth over a WebSocket connection, which is both identified and authenticated using the URL in this text file. And then separately it gets the texture that's used for this overlay. It would probably look pretty weird right now if I just gave it a random image file for this. Oh, it crashed. Cool. Oh, maybe this isn't a crash. Sometimes the file picker dialogs seem to just throw C++ exceptions when they're opened, but then you continue and it's fine. But now Visual Studio is hung a little bit, which I've got a chain of deadlocks here. Ear is asking, did you figure out how OBS was relying on the broken features you fixed? Oh, right. So I spent a lot of last stream realizing that OBS, so they have like a graphics middleware layer that they use to implement their subset of what they need out of graphics on top of either OpenGL or DirectX. And I found out that that middleware layer just completely flat out didn't implement a feature on Direct3D that it advertises. And it's the feature where you can choose whether or not you're writing to each color channel on the output. And so you need that if you're doing the alpha blending using the alpha channel, but then you want to control whether or not you actually write that alpha to the target. So usually if you're doing the blending, you don't want to write the alpha because you want the target to have that 1.0 alpha or whatever stay there. But if you were, in this case, if you're just using that write operation instead of to blend, but just to copy the pixels, then you do want that write turned on. And so that distinction was important. And I implemented the missing feature, and then I discovered some other stuff that just was broken. And actually, I traced that back to my own code. So I mean, it was a combination of my own code and, I guess, bad documentation. So there was a convention that I was unaware of in OBS where if you change the write mask to anything other than 1111, then you have to change it back when you're done, which makes sense. I thought that the write mask was included in this pushable, poppable blending state stack because it looked like it was part of the blending state, the way the API was designed. But it actually, when I looked at that code, it was not part of the stack. So my plugin, I thought, was saving that state, and it wasn't. So it was actually my own plugin was corrupting that state that I fixed, and it just wasn't visible until... So it was like my own bug that I created and then fixed. So... and then I managed to mess up my Git repository because my first commit ended up saying in the commit message, like, oh, this seems to break some other stuff. There'll be some forthcoming commits to fix that. And so after I fixed it, I wanted to remove that from the commit message. And so I used git amend, but I forgot that I had already pushed it. So then I ended up with like 2 conflicting commits in the remote GitHub repository. So I just had to learn how to do some GitHub surgery, and someone here in chat actually gave me the hint on how to fix it, and so I got that actually fixed and submitted a pull request just in case the OBS authors care. But either way, it's in my local fork of OBS, and so that's fine. Let's see if I can continue. Oh yeah, it didn't crash. That was just the file dialog. Sweet. Thanks, debugger. Yeah, so what if I just set this to some other image? What do I have on this computer? Let me go find like an interesting art directory in my Dropbox without showing you the entire directory structure of everything. Oh, these have to be PNG files? I guess the API I used needed a PNG file. What could I give this that would be interesting? I've got a lot of PNG screenshots in my Dropbox. This could get a little meta. Let's just try something like this. Just like a picture of this project. What if I give it that as a texture? Oh yeah. That's pretty fun. So, okay. It's still possible to escape the correlation tracker if you move really sharply. It might be worth just reading the source code to try to understand how it works a little better so that we can increase the search distance. Because yeah, it's really way too easy to lose it. But it is running a lot faster, and it's much better than it was. Oh, good question from Emily, who says, title says mail, did I miss package opening? No, I was actually about to get into that. I just keep getting distracted by explaining and then breaking random parts of this infrastructure that we've been working on. Let me put this texture back. So yeah, the tracking is okay, but it's easy to lose it. So, like, whatever parameter I can change to make it harder to lose would be nice to tweak a little. Oh, George is asking what it would mean to open source the project. The project is already open source. If you go to github.com/tucoflyer, you will find all the source code. And it's all under open source licenses. I think it's all MIT licensed. I don't know if I've been specific about the license for the CAD stuff. I should probably like throw Creative Commons on there or something, but I intend for it all to be open, so anything there that is not labeled as open source, that's just an oversight. And yeah, there has been a lot of stuff, but it's all in the GitHub. Let me show you. github.com/tucoflyer. This bot controller is the Rust software, which also includes the web front end. So there's a lot of JavaScript in there too. There's the OBS plugin, which also includes the computer vision. This is the fork of Darknet. These are the CAD designs. They were made in a combination of Fusion 360 and Rhino, but I've got STL files and step files in here, as well as whatever other source files I had. So that's a lot of stuff we got. Wow, that's trippy. I've got a clear window. Speaking of rendering transparent things into RGBA textures, yeah, so you can often do that with Windows also. I was experimenting with this a while ago, and I made a macOS application that was just a rotating cube on your desktop with no window borders, just transparent. I thought it was funny. Now you can see my T in the Diagnostic Tools window. It also used to be common to see that for a completely different reason when we had hardware that did chroma key overlays. Actually, it's possible this is using a chroma key overlay. I kind of doubt it. Yeah, no, because that would only show the video, not all the UI stuff. That's definitely a transparent region. But yeah, like in the 90s, you would see a similar effect because a lot of times the video card would composite the video on top of the scene using a chroma key so that it could handle all the window occlusion automatically. Elman says, diagnostic window, look at the problem yourself. Yeah. Aw. Corporate Warrior on YouTube says, why are you so smart? It makes me feel stupid. No, it's not, I don't think it's like, I don't think I feel like this is about intelligence. I feel like it's about the amount of time I've had to just like fuss with this stuff and get a sense for how it works. So, you know, I try to just share more of this stuff so that I can help more of you, you know, get some of it by proxy, so that even if you don't have as much time to learn things, that I can give you, you know, enough of it by osmosis that you can figure out where you want to get started and making your own projects and doing experiments and learning things. Because I've always learned best by just having a project to get interested in and having some stuff to take apart. Anyway, we'll come back to that in a sec. I think let's switch to the desk camera of some sort so that we can do this unboxing. Oh, I see. So I think George was maybe not asking about the code being just open, but maybe about it being reusable. Yeah, no, that's a really good question. There are certainly places where, you know, I've got a lot of this intention to make it well architected and modular and separate and all that, but like, for example, if you wanted to just like slot in a different kind of gimbal, right now that would require doing some surgery on the Rust code, since there's, I mean, my approach to that has been more about exposing as much of the low-level stuff on the gimbal as possible, even when the system is fully assembled, so that I can continue to reverse engineer the gimbal while the robot is running. That said, if you were to kind of just rip out that bit of functionality, the interface between the gimbal and the tracking system is mostly like, if you can tell it where the gimbal is and you can get control rates back from this to the gimbal, you could put the two back together, but yeah, no, there are certainly pieces of this that are probably pretty reusable. Like, if you wanted to reuse most of this OBS plugin, you could probably even just reuse the binaries and just try to be compatible with my WebSocket protocol if you wanted to. Yeah, no, if I suspect what'll happen is if there is a need for this to have support for multiple gimbals in the future, which seems likely, like if the system becomes popular and people want to build their own with different gimbal brands, then I would just need to just refactor it a bit so that there would be maybe some layer which has more like low-level gimbal stuff that you can like kind of hide away if you're not actually developing gimbal-related stuff. And then the actual interface between the control loop and the gimbal could be a little bit more narrow. But right now I'm just kind of still developing all this stuff, so it's easier to keep them all in this loosely connected pile of objects that I gradually split parts off from. So that's part of it. Aw, Rodrigo in YouTube chat says you're an inspiration. Oh, thanks so much. Well, I hope whatever I'm doing keeps working. Oh hey, I wonder if I can actually use the robot camera for the unboxing. I wonder, because I was about to use the desk camera, but this might actually be a little bit better if I can point it this way. I might need to move it so the pole isn't in the way. Got a little wobble when it's bouncing up against the vertical limit. It's not the worst camera operator I've had, but now the pole's a problem again. Hey, Tuco. Alright, let's see if this works. It is tracking all sorts of weird points now. I mean, without it knowing what to track, there isn't that much hope. It's just kind of following correlations. Oh no, packing peanuts! Oh no! Oh no. Yeah, I know that was not the right way to use the scissors. Oh no, packing peanuts. Yee. Does the computer vision know this is a trash can? Sometimes it detects it as keyboard, but I don't think this looks like a trash can quite enough for this. This is an interesting moving camera perspective I'm getting now. Whoa. Oh yeah, here is the box. Whoa, no. I'm gonna keep these away from Tuco. Okay, the robot camera's not doing too bad now. Right now it's tracking the edges on the packing peanuts. I've been kind of thinking about what to do as far as on the stream, like how do I want to represent the area that it's focused on. Since it'd be nice to display something there, since it's, you know, seems useful and interesting. But I don't want it to be distracting, and I'd like it to convey the information that's relevant in a timely manner without looking sluggish. So just smoothing out the rectangles with an exponential filter, like, you know, a lot of people have suggested that. That would work, but I don't think that, like, that would not actually smooth it out that much, since a lot of the jitter would still get through. And then you'd be losing a lot of information about where specifically it's jittering between, which right now actually kind of makes a lot more visual sense than something that would have gone through a filter, I think. So I kind of like the idea of doing something in image coordinate space. So one thing to do would just be to have some kind of accumulation buffer that basically does a motion blur of like fuzzy rectangles over time, which maybe would be better. But I think that would still have some of the responsiveness problems of just filtering the rectangle coordinates. So I think my favorite solution so far is actually to have just like a little particle system. Like imagine the dotted rectangle outlines that you would have in Photoshop or like graphics editing programs. And I don't know, maybe I'm remembering something even older than that, but there was a classic kind of outline where you draw a rectangle around something, and then it would look like marching ants. The rectangle would have little alternating black and white dots that it would appear to move in a circle. And so I wonder about doing something like that, only with a particle system that, and you know, it wouldn't even need that many particles. I'm imagining like a couple dozen, and they would all just turn into sprites on the in this same vertex buffer that's doing the overlay rendering. And they could be little rectangles, they could be little image sprites. If I wanted to get fancier with it, then I could start doing this on the OBS side, on the GPU, and then do some fancier shader effects, or do something with, anyway, just like some fancier particle system thing on the GPU or whatever. Because I know it would be nice to see what the tracking algorithm is focusing on, but without the distraction of the full debug view. So that's something we can implement pretty soon. Mikey suggests soft filter around the point of interest. Yeah, that's something else that kind of came up, is like maybe some vignetting, or I guess you could even like blur out stuff that isn't right in the center of the frame. Although that might be, like if it's a very subtle blurring, then it might be hard to notice that over more compressed video feeds, like if you're watching it on Twitch on your phone. And if it's a more intense blurring, then that might just make it annoying to use, because you wouldn't really be able to see the scene aside from right where it's looking. And you know, maybe there's something that isn't a blur, but is maybe just like a contrast effect or something. Maybe that would be fine. And yeah, that would be something else where, if it's just a, like if it's just like a feathered edge or something, like one really simple way to do that would be, I don't know if anybody knows the kind of old like GUI design trope of, you know, you want to give someone a configurable way to skin a button or something else that can change in size. So you have them draw on a grid that's divided into 9 squares. And so the idea is that the corners stay in the corner, the edges stay in the edges, and the center expands. And so the center of the edges, for example, will expand to fill that entire edge, and then the corners stay there. And so that kind of thing, like you could do that with varying degrees of stretchiness, so that the center and the edges expand a different amount, and then like use that to position some alpha blended sprites on top of the scene, which could be, for example, you know, they could be like fully transparent in the middle, and then like kind of taper off to opaque, and then they could just like clamp there for the rest of the scene. I don't know. Yeah, I think my idea with that 9 region thing would be that the center region would be around the region of interest, and then those other 8 quadrants could actually expand around that and fill the region between that and the edge of the screen. Anyway, that's neither here nor there. This is tracking my elbow now. Come on, go back up on here. Did I push it? I did. All right, so we've got this, the IntelliKeys USB keyboard. Oh, Tuco, don't eat that. Okay, I should actually fully unpack this and put away the packing peanuts, because Tuco will want to eat them. Is that everything? Alright, let's put this somewhere Tuco won't get it, and then we'll be right back. Oh, I found Tuco. I think that worked out. Oh, that would be cool. Mikey suggests black and white outside the interest rectangle. Yeah, we could like desaturate it. That could be cool. Oh, and then Whisperfist says, I like the previous mention of particle swarm overlay, particularly if text labels had more inertia / hysteresis. Yeah. I mean, so I like the idea of the debug data not to have smoothing on it necessarily, but to have a separate thing for non-debug rendering. So I guess that also brings up the possibility of, like, with labels, like, because I've been assuming that the non-debug rendering of the rectangle around the target wouldn't even need a label. Like I could just use different colors or different properties for the swarm to indicate different statuses. But if I wanted to label the objects detected by the object detector, for example, then yeah, I mean those could have filtered position. That would just also require kind of grouping those labels into more temporally coherent bundles of stuff. Oh man, right now the tracker is just... Actually, no, this is the object detector bouncing around. So I was thinking about so this is also something I need to fix. The gain system for actually controlling the gimbal based on the tracker results. This is like version 2, and I've got a plan for version 3. Version 1 was just a straightforward proportional loop, which was okay, but didn't respond very fast and was overly twitchy. And this one is less twitchy when the target is small, but still really twitchy when the target is big. Actually, much more twitchy when the target is big. So I think this one was based on specifying a bunch of rectangles and then calculating the overlap between those rectangles and the target rectangle, the tracked rectangle. And the area of the overlap would be multiplied by a gain vector and then added to the those rectangles, proportional and integrated. So proportional gain would be based on how far into the gain region are you. And then, see, this didn't even follow him. That was useless. And then integrated gain would be restored to 0 when you're within the dead zone, like in the middle where it isn't moving the gimbal. And then integrated as long as you're not in the dead zone. So I think with the combination of those controls and dead zone size and multiple gain regions per axis, so you can have like a soft gain region and then a much faster gain region near the very edges of the screen, I think I can get better behavior that way. So that's on the list of stuff to implement today. It's tracking my elbow again. I should have an option to enable person tracking. Actually, I could do that. Let's not get too sidetracked though. We've got a package here. Yeah, right now the only thing missing is actually some configuration UI for that. There's already a config file that just you list object categories and minimum confidence levels. Oh, Velcro. Oh yeah, there's t-shirt. Sweet. So you should see me wearing this on the stream tomorrow. Got an ATMakers.org. Can we correlation track the logo? Yeah. So got a delightful V-neck t-shirt. That's pretty awesome. With the ATMakers logo. Helping makers help others. So that's pretty awesome. Thank you. And then we've got user's guide. Let's put this aside. Oh yeah. This is from the Assistive Technology Resource Center in Houston. Yeah, so there's instructions on all these different overlays, which are different ways of using the keyboard and different labels that go with it. And how to write your own. Hey, Tuco. Oh no. Yes, there's overlays for using the keyboard as a virtual mouse. There's overlays specific to websites. So these are like very application-specific virtual keyboards that you can actually load onto this physical keyboard. Oh, Tuco, I'm saving that for later, honey. Oh, cool. So that's the user's guide. These are the actual overlays. So I think the idea is that these are supposed to be pretty easy to change quickly. So they just slide in. Installation CD. Might need to find an optical drive. Install this software before you plug in. That doesn't have autofocus, sorry. We'll be going into this in more detail on the stream tomorrow. This is just kind of a unboxing experience. Can I get the camera's attention now? Oh yeah, Elman says, just a thought, help speed up Tuco location by triangulating meows with mics on the winch bots or directional mic array on the flyer. Yeah, actually, I've thought about using microphones for that. I mean, it would be kind of interesting for Tuco. I think it would be especially interesting to try to locate bolts that way, because then you could tell, like, well, where does Tuco want to play with the bolt? And if you had a little mobile bolt robot, it could go find that noise. And the floor here is concrete. I might be able to just get away with attaching contact microphones and then use the propagation of the bolt clicks through the floor. So it looks like I've got one overlay here. And this is the setup USB overlay. Oh. Well, that's interesting. Now I'm curious whether these, so it's listing things like you can use these to change the repeat rate and stuff like that, and now I'm wondering if these just end up going into the application or whether some of this ends up happening in firmware. I think I should actually switch cameras for that. not have... Am I completely missing the DSLR? I think I'm completely missing the DSLR. Thanks, stream. I think this is the kind of problem that I would fix by either restarting OBS or like removing and reinserting this source on every one of my scenes, maybe? I don't want to do that. Oh, that's super annoying. Do my other SDI channels work? This is SDI. This is SDI. It's just the HDMI for the DSLR is not coming in. Let's see if I can get it using a different program. The device seems to be in use, as I would expect. Okay, well, I guess until I fix that, I am stuck with this camera. Or this camera. This one at least has autofocus. So yeah, got this overlay. Oh yeah, Bill was pointing out this feature to me. It has these little optical marks on the side that it seems to use to identify the different overlays. So I don't quite know. I mean, I'm assuming they're optical. They might be magnetic, but they're probably optical. Maybe that's a start bit and then one significant bit, perhaps. Yeah, as Robert's saying, it's kind of weird that I've got only one input malfunctioning, but I've had this problem before, and I just restarted OBS and it was fine. I don't think it's OBS's fault necessarily. It certainly might be, but wow, this device is nice and sturdy looking. So it's like a plastic cafeteria tray almost. And then on the back there's this metal hinge. Tuco is going to distract the camera. And then we've got, oh yeah, full-size USB, USB-B. And then just a big touch surface. You can feel a grid in there. I wonder if this is one of those like high durability resistive touchscreens. Because I remember some touchscreens where optical clarity isn't a big deal. Like in this application, you can use a separator that's a lot more rigid than the like little glass beads they often have to use in touchscreens. So maybe that's what this grid is. Seems to just be providing a uniform texture. And then lights and inputs for external switches. Let me nudge this camera up a little. I'll be sure to make sure all my cameras work before tomorrow's stream. So yeah, external switch inputs on the left, some lights on the front, touch surface here, and USB cable. So we will dig into this thing and take a look at what its firmware is like, what the hardware is like, how we can try to improve the lifespan of this device and help out the folks who rely on it. So yeah, if you are around tomorrow during the day, we're going to be doing this in the morning, my time, in the afternoon, his time. So 11 a.m. Pacific, 2 p.m. Eastern. Yeah, and there will of course be a recording afterwards. We'll take a closer look at this thing. All right, Tuco is under the desk now. Harrier Pigeon says cattails have exactly 9 degrees of freedom. Oh man, Robert is the source for all the cynicism you might need. They're saying, I assume this won't be just a HID device, need to have value add after all. Well, so imagine, like, what are you using this device for, right? You're using it as an input device that has this sort of customizable macro layer. So that macro layer needs to be implemented somewhere. So either you've got a macro program, which is then getting data specifically from this device, and in that case, you actually don't necessarily want this to even be a standard HID device. So I wouldn't be surprised if they use a vendor-specific protocol for that reason, because they want to be communicating specifically with their macro software. Or if the macro software lives on the device, they still need some extensions to be able to configure the macro software. And then the software probably needs still kind of a back channel to the PC to do some stuff that isn't possible with standard HID, like opening applications. Oh, good question from Rodrigo, who asks about the connection between darknet and dlib. So they're actually totally separate. You can just imagine that there are, well, actually, why imagine when I can actually draw a diagram? Do I have any DaveCAD documents handy? I think I brought my copy of DaveCAD with me on that conference. I might have left it in my bag. Let me see if I have that handy. Oh, Tuco left. I found my DaveCAD though. Oh man. And now Robert is saying that, well, yes, theoretically you can just like do arbitrary stuff via the keyboard. But yeah, you might not want to have to like Command R and then type a bunch of things to do, but all the usual stuff you want to do with your keyboard. What I'm trying to say is, like, there are enough reasons why they would want a communication channel between the hardware and their own agent running on the computer that I'm almost 100% certain that exists and is the main thing that they're using, but like, no doubt there are a lot of cases where you wouldn't necessarily need that, and that's a good example of what we could be doing with this custom firmware is, for example, you could like open a web browser by automating a macro sequence like, Windows R, enter a URL, that kind of thing. But that's like the kind of thing where, like, if you have a fairly featureful macro playback engine on this thing, then you can implement a lot of stuff, including that, and we don't really have to do anything super application specific in the firmware at that point. Am I just not going to have overhead camera at all? That really sucks for this. You know, this is almost worth doing a really quick OBS reset just to see if I can come back, because I really want my overhead camera. Oh. Mikey says that little purple ring is amazeballs. Which purple ring? I'm happy you found something awesome, but I don't know what you're talking about, sorry. Alright, well, I'm gonna try restarting OBS because I want my camera back. So I think I'll be right back if this goes well. I'll see you in a few seconds. Just try to reload if you don't see it come back right away. Well, that didn't work, I'm sorry to say. So I might need to find an alternate camera strategy for this particular stream. I think I understand the problem a little bit better. I think the video capture device I'm using is a 4-input PCI card, and I think that half of it is kind of crashed at the moment. So I think this necessitates a reboot, which I don't really want to do right now. So maybe let's avoid this for the moment, and maybe I can share this with some other camera. Maybe I'll just... Oh, and now someone's cutting metal outside. That's cool. Blah. Okay, well, I'm just going to draw this on DaveCAD and then hold it up to the monitor. I was just going to try to explain what we're actually doing. That's right, we decided that did not have autofocus. Sorry about the equipment problems this time. Man, it's really frustrating when I just have to reboot the machine that everything is running on. Okay, so I hope that's at least somewhat readable. I'm just trying to illustrate what's going on inside OBS here. So you have the camera source, and then that line on the left. Can I actually hold this more steadily? That line on the left represents the rendering thread. So it's going to just be doing a bunch of things in sequence as the graphics rendering in OBS progresses 30 frames a second. So the camera will eventually result in something that we can access as a texture. So it'll probably come in through system memory. There's an async frame upload in OBS, but then eventually we can just render it as a texture. So then we have these two objects that are image grabbers that can render that camera Well, we don't necessarily know that the camera is always a texture. Actually, there are some edge cases in OBS, so it usually is a texture, but we might have to do a system memory upload, or it might be some other render target. So the grabber actually right now is pretty conservative in how it uses the OBS API, and I always render that into another render target at an intermediate size, and then I render it again using a scalar shader so that I have a small version of it at the right size for the neural net or for the dlib tracker. And then once I have the scaled version of that input in system memory, that little Q next to it represents a FIFO of images in system memory. So that stores images as they come in from the camera. And then asynchronously, there's another thread running the computer vision, which processes the images. And then anytime that has a result, it sends out a packet via the WebSocket back to the Rust server. And then after doing the grabbing, the rendering thread draws the overlay on top of the source. And it also draws the source, and then it draws the overlay. And the overlay actually has a double buffered vertex buffer attached to it that also gets written to by the same WebSocket thread. So. Oh yeah, Ryan says you can tell when you're running a Tuco cracked version of DaveCAD by the presence of cat hair. Ain't that the truth? Yeah, there's some obvious cat hair on this one. Oh, and then a couple folks have pointed out that that purple ring was under the chair. Oh yeah, that's a bit of plastic trash. The camera is pretty fixated on Tuco right now. Tuco's got an obvious bolt there too. Currently this is just acting as a SDI pass-through, so you can see a copy of that image on the screen. Yeah. Okay. Well, I think it's time to get to the next thing. I think the next thing I wanted to do was to try to test whether the downsampling that I added to that grabber is actually working well. So it's certainly not the most efficient downsampling. I wanted to be sure the last couple of layers were pretty good, so I have a single, well, I don't know, how deep do you want to get into image resampling theory? So, I mean, resampling in general can be a super complex topic because resampling anything from one sampling rate to another without introducing additional artifacts is, I mean, it's super complicated and doesn't, like, you can't really do a perfect job in the general case. One thing that's a much easier subproblem is if you want to scale down by a factor of 2 or a power of 2, because then you can just repeatedly keep scaling it down by 2, which is actually both conceptually really simple and also really easy to implement on GPUs. So what I'm doing here is actually, it's not very efficient, but it was just like an easy thing to code, and it seems to work well enough at this point, is I'm actually using OBS and its default scaling, which is usually bilinear interpolation, but it could be whatever the source is set to. And I'm using that to scale the source to 4 times the eventual resolution that I want. And so that step uses a bunch of GPU memory, and it's not super efficient. And then I have a second step which takes that larger image and uses that as a source for a single operation which scales down by a factor of 4. And this is 4 in each axis. So I want 16 samples. What it actually does is it samples 4 times right at the intersection of the pixels. So I'm asking the bilinear interpolator to actually do 16 samples for me. So, yeah, well, as Robert's kind of implying, Robert says resampling without a band limited assumption is really, really fun. So, Yeah, so what Robert's getting at with band limiting is that when you have a sampling rate, you can't represent frequencies above the Nyquist limit, so half that sampling rate. And if you have something like really stripy, like Tuco or the rug, for example, or the edge of one of those vertical poles, then without the right resampling, you'll see that shimmering because you're actually taking those higher frequencies and sampling them irregularly so they can actually fold back down into lower frequencies. So instead of that single high frequency edge, you see kind of a repeating pattern of high frequency shimmers at a lower rate. And that's actually an interesting entry point into some complex areas of signal processing. If you actually want to learn how to resample images in a really high quality way, then you end up having to go very deep into signal processing. I just wanted something that I could implement quickly and have a pretty good idea it was correct, or at least correct enough for this application. So I want to see how close I got to that. I have some debug support for just writing out the computer vision data as a sequence of PNG files. So I'm going to enable that and then wave around a checkerboard in front of the camera and then convert that to an image with FFmpeg, and we can see how good the results are. So I think we've got to go back to the code editor. We actually want the OBS code. All right, so we've got image grabber. This is the thing I was just talking about where we have a shader that does this 4x downsample. And then in the render loop, we do some resource allocation if we need to. Hopefully not very often. And then here we render the OBS source using whatever rendering function it's provided at our own scale, so we can squish it a little bit. In this case, we're actually expanding it to something, well, probably expanding. It depends on the particular resolutions, but we're scaling it out to something that's 4x the eventual resolution we want. And then we're just doing a downsample in one more pass. This is definitely not the most efficient way to do it. It was just the fastest thing that came to mind. So this itself, it doesn't really have any fancy image format stuff. It's calling this, so when we do the readback in here in post-render, which is a little bit later to give the GPU some time to catch up, it maps the staging surface, which is a piece of memory that theoretically we can access both from the GPU and from the CPU. How this is actually implemented is kind of up to the driver, but the abstraction it gives us is a function that maps it into something that we can kind of access from system memory and a pointer. The driver is completely free to implement this in a way that just mallocs something and like copies the data in here when we call map. So the interface we get is a pointer. Then we call this RGBA to image to store that data in some arbitrary output format. And the output format depends on which computer vision algorithm we're powering. So for the tracker, that stores it in this dlib array. I switched the tracker to using a color array. Since with the scale estimator disabled, we had some CPU power to spare, so I turned color back on. And here's the code I added to dump out images. So I'm just going to turn this one on. This will only dump out images for when we continue tracking. We could also dump out the initialization images, but just turning on one should be sufficient. And then let's restart OBS. The diagnostic tool stopped being transparent. Yeah, sorry about the hiccup. Thanks for coming back. I'm especially sorry that my camera still is not working. It seems to need a reboot. I guess I could grab an HDMI extension and plug it into a different input And that might get it kind of working. All right, there's OBS. We should be getting a bunch of frames right now. Let's verify that. Frames. Okay, let's just remove these all to make sure we don't have old ones. And we'll just be getting new ones continuously. And hey Tuco, what do you think about checkerboards? This isn't even a checkerboard, this is one-dimensional. Len says, I now associate the metal grinding sound with imagery sampling. Yeah. I'm not actually trying to get it to track this, but it's kind of funny that it's trying to anyway. I just want to move it around at some different scales so that I can look for artifacts in the image. I think that should be enough. Let's process what we've got. So turn this flag back off before it fills my disk with unnecessary images. But run this again so that it resumes tracking my cat. I wanted to tell this to do lossless encode. What was that flag again? Some flag, which I'm not seeing here, which is some quality metric that you can set to 0 to get it to be lossless. Why isn't this in the help? CRF. Oh, good question from Alistair, who asks, did you make some improvements to the correlation tracker since last stream? I got it to run faster for sure, and I think I'm giving it a much better input image. So I can run it. I'm giving it a better image. I'm giving it a lower resolution image. I'm giving it. I have the scale estimator turned off, which was using a lot of CPU. And then I'm using more of the free CPU to add layers to the regular So I still don't actually know enough about this algorithm to even explain what the first parameter does, but there's some parameter which is like a number of power of 2 layers in the search space or something like that, and so I can increase that a little bit, which helps. It does seem to have trouble with images that move a long distance, so one thing that would be useful is to go understand the algorithm enough to be able to optimize that. Seems okay. So this is intended to be low resolution. It's low res because these algorithms don't need that much resolution, and you can save a lot of CPU by downsampling the image. This is 256 by 256. Whoa. Oh, it finds Tuco on its own. Well, that's great. Thanks, little camera. Okay, I think that's working. Cool. What's next? Oh, that's delightful. Okay, I think that's fine. I've tested it for Moire, and I think it's all right. So, I have a bunch of other things to fix. There are a couple of little easy fixes I might do, and then one other kind of chunk of stuff we could bite off is adding, doing a slight bit of refactoring to the Gimbal controller so we can access some state outputs from it elsewhere. Alright, that doesn't really have any changes. Oh, Tuco is just so pretty. Ryan is asking how I'm going to do the machine learning training on my own cat. I hadn't thought about it that much, but there are a lot of ways we could do that. I mean, one way would involve collecting data using an existing pre-trained network as kind of a seed data source, and then having some refinement using, you know, either some manual labeling or maybe a combination of multiple models. But the idea would be to collect more data based on this particular shop, so positive and negative examples from here. And I think I could maybe just use some of the existing quality metrics here to reinforce the stuff that it detects that consistently works, and then to, I think I could basically add some code to the flyer which helps harvest training data for neural net improvements. Len says it's nice to see Tuco Flyer working as the regular cat cam. Yeah, I'm happy with this too. I've still got the tripod right here, and it's easy to plug back in if I need it, but maybe I can actually take it apart soon, which would be nice. Okay, I think I want to do no more tracking resets. That would be nice. That's on the Rust side. Yeah, I think I'm just going to remove this tracking is bad detection. There's some corresponding config items we can delete. All of those. It's kind of fun, you know, being able to restart just the OBS side or just the Rust side and still having some of the bot functionality work. The biggest annoyance here is without the Rust software running, there's nobody minding the Gimbal's end stops. Oh, we have no reset tracking route. Sure. It's probably something bad about changing the source code while Rust is building it. Alright, well that runs. Oh yeah, look at that. See, the correlation tracker is now so much faster. Not from that change. That change was just to remove some tracking resets I didn't want, but most of the speed up is from removing the scale estimation, and some of it's from changing the resolution. And that's pretty stable. So, and then it starts wobbling. That's pretty stable as I momentarily pass through it, though. And that's got a pretty high PSR, like 25. Good tracking usually seems to be anything above like 4 or 5 or so. One thing I've been doing is recording this while the tracker stays fixated on a region so I can see how stable that is. Let me see if I've got some time lapses from earlier to show while I'm doing it this time. It is really depressing how long it takes Windows to sort these files by date when it opens the directory. Like it has to download all the thumbnails before it can sort them by date or something. Now I'm just complaining. Oh, here's the one from earlier. This is at 64x. Yeah, let's try faster. 256x. There's a little bit of drift, but see, this correlation tracker is pretty stable over time. That's one thing I really like about it. You can see how when it's tracking, there's a region in the middle of the screen where it doesn't really try to move the gimbal. And so everything just kind of floats to one edge of that region because of the gyro drift. So another thing on my list of stuff to add is another term in the gimbal rate calculation that nulls out gyro drift. And at first that term can be manual, but we could, I'm not entirely sure how to do it, but I've been thinking about ways to automatically calculate the gyro drift nulling factor. And so maybe, for example, it can look at, like somehow bin the average. Like if I have a smoothing function attached to the rectangle position, and then I calculate the derivative of that smoothed rectangle rate, that over time, I'm going to have moments where that is my, would converge on being my gyro drift rate. Like when I'm just looking at something straight ahead and everything is stable, like that would actually, if I averaged it over time, give me a good estimate of the gyro drift. But if I just averaged all of those, they'd be all over the place. So maybe a way to bin those samples so that the ones where it seems like we're pretty close to zero, we take that not quite zero and average it over time and use that for gyro drift compensation. I think that's, oh, did this get distracted? Oh, did this see a cat on the screen? Is that what happened? There's another thing that I think I might want to do, where I actually keep a log of all the object detections that it triggers on. Be like, why did it move over here? That one might be relaxing. I mean, now you can just see it fighting against the up and down gain rectangles. Anyway, crossed an easy thing off the to-do list. What's next? No more tracking resets. Man, so much of this, I think all of this is about the gimbal at this point. I had a patch stashed in my Git stash that I did some of this. I think we want to continue that now. This is great. Can we just appreciate this full screen for a sec? If I get up to get more tea, Tuco is going to try to follow me. It does feel pretty neat how it does, you know, kind of tilt a little bit to move the cat around. It's sort of weird when it doesn't seem to have a reason. Like, why is it focusing on going down so much right now? Right now it's, the object detector is detecting Tuco's face intermittently, and then it's tracking it pretty well. Wow, this combination of the two algorithms is actually working pretty well right now. Alistair says Tuco's mica tracker is top-notch. Right? He seems to be able to differentiate me quite effectively from any human, too. You know, other people are around, but he just wants to curl up next to me, and it's really, really nice. It's funny how it looks like it's centering Tuco's face, because that's not actually what the algorithm is doing if I show you what's going on inside. This is another one of those cases where the rectangle that it's drawing around Tuco is now kind of bouncing up against the gain rectangles for the gimbal tracker. So there's a gain rectangle that ends kind of right here where I'm drawing my mouse, and then another one that ends like right here, and it just ends up right up at the end. So I'm changing how those gain rectangles work, but the bouncing up against the end is still going to be the case until after I get drift compensation working. And it still might happen over time with the drift compensator. It just might be more random. It wouldn't always go to the same corner. Ah, Tuco's tail is so nice. It is really lovely. I like this cat so much. And the object detector is so fast. Oh yeah, these sliders are broken now. I need to remove those from the web interface too, and I guess I should commit this change. Maybe committing it would be good. Just those three. Yay. Actually, can I fool it with my lock screen on my phone? Because that's a picture of Tuco. It's detecting it as a phone. It's not really focusing. I don't think it's quite distinctive enough or big enough right there. But I thought earlier it might have snapped onto a picture of Tuco on this monitor here. All right, check in. Supply the stash and break everything. Oh yeah, conflicts everywhere. We auto-merged the config file somehow. How did that happen? Actually, I think I just want to discard the changes to both of those files. Oh yeah, so If you didn't see the resolution of our stream yesterday where I thought I found a bug in OBS, I did actually end up filing a pull request about that one. Excuse me. Oh no, the CI build failed? How did that even happen? How did this fail on Linux? It was part of the D3D backend. This looks a lot like their build machine isn't configured right, but I don't know yet. Huh. I don't know, man. Maybe they want my patch, maybe I don't. Maybe they don't. At least it's in my fork. It was really simple. I replaced a thing that was obviously not complete with the obvious implementation of it. And it's been working for me. It's in the Direct3D backend, so it shouldn't even be building on Linux. Oh, okay, Ryan says there's another issue open for Linux CI build failing. Okay, I guess that probably isn't my fault. Oh yeah, Git surgery. I did have to do some Git surgery. I think I successed at the Git surgery. What do I actually have over here? I think I'm gonna need to make more coffee if there's gonna be a bunch of metal cutting. Anyway, so I think the only substantive change here is in message.rs. How is that? Oh, right, because it's already staged. I think let's try unstaging it. Cool, this is what we want to be editing. This is completely not ready. I just started adding a new enum and then didn't even finish it. I think I wrote this late last night and then went to bed just to mark my place. Okay, cool. So my idea here was to add another kind of packet on the message bus, which goes out anytime the robot controller thread runs its own Gimbal loop. So the idea is the message bus already has its own messages that go back and forth for our actual communication with the gimbal. But in addition to that, I wanted to have some way of conveying the state of the control loop itself to outside entities like the WebSocket clients. So my idea with this was to be pretty straightforward about it, and this is another thing where I'm adding something that would need to be changed if I'm having a bunch of significantly different gimbal algorithms that you want to plug into the same robot. But I'm planning on just having a single serializable Rust structure, this gimbal control status, which I just pack everything into. And I probably have a function on my gimbal controller sub-object, which runs one tick of the control loop, and then just returns one of these gimbal control status objects. And then the caller of that object will just stuff that onto the message bus. And then I can easily add graphs on the WebSocket client side that just show all the gimbal details. And that's what I'm looking forward to. The other wrinkle in this is right now these Gimbal value messages, I think we're only getting them for incoming values, not values that we've just sent to the Gimbal. And I don't think that would be a replacement for having Gimbal control status packets, but it would actually be nice to see the outgoing data as well. I wouldn't want the Gimbal poller sending those out because that's kind of the controller thread's responsibility. The controller thread is the one generating messages about the status of the controller. And it's ultimately the one generating all the messages, so other messages have to be bounced through the controller thread. Usually the controller is acting on them in some way first. This is why I haven't implemented it so far. It doesn't quite fit into the architecture cleanly, and it's not that important. Look at how the Gimbal controller works right now. So controller state and controller, the main ways that they're separate is that controller state is this object which is mostly mutable, whereas controller has a bunch of stuff which kind of can't be mutable because it's associated with communicating with other threads. So controller itself has turned into this thing that's basically entirely about the inter-module communication, whereas state is then the kind of guts of this thing. So it gets function calls, for example, that are like recalculate the lighting or update all the tracking stuff with this time step. And tracking update, for example, gets called a couple places here. So there's the timer-based tracking. There's also more tracking when we get object detections in. And these are Gimbal writes that come in from an external message. So like if we're in the web client and we want to write to the Gimbal, then we send a message command, which goes through this loop, gets broadcast out to the Gimbal, and the command itself also goes out on the message bus so we can listen to what other modules are doing with the Gimbal. But internal to the controller, we don't have to go through that route, and in fact we don't. So we just call like gimbal.write control rates, which is then a function on this Gimbal port object way over here. And that actually just formulates these two packets and stuffs them in the queue. So if I do have a write message, maybe it would be a write confirmation, because it would be nice to know when the data actually goes out to the Gimbal. I came really close to actually implementing a solution for this, and I might go back to that idea, where the idea was that the poller, so the same thing that gives us information about reads that have completed, it could also generate the same kind of packet for writes that have completed and just differentiate them with a new value that indicates like why this value is being updated. Yeah, so the poller itself runs on the thread that does the network communication. It has these channels that receive messages from other threads. In this case, it has different channels for the different data types it could be receiving. So packets that are just like raw Gimbal packets to be sent, writes, which are combined into a buffer of writes that are then scheduled for later, or requests, which are combined into a buffer of requests that are scheduled to be read back later. So right now, handle packet is for incoming packets. This controller port is how I write messages back to the controller indicating success or failure. I think what I'm just now realizing is that what I'm talking about pretty much just amounts to having a completion callback for asynchronous writes to the gimbal. Because right now you write to the gimbal, you don't actually know if it ever finishes. You could get notified by adding a read for that same value so that it'll pull the same value, then you wait for that to come back. But that is slower, and it would be nice to be able to differentiate those from... It'd be nice to be able to get a notification that the write is finished, and then also if you want to read, for that to be able to be a separate thing. So that might just mean that controller needs to be an argument to send next batch also, which is where we send outgoing packets. Who else calls send next batch? There's a timeout, right? So check for timeout, I think, would also need a controller port reference now, which should be fine. Plumb this down into here. So a couple of layers here involving the I/O buffering. But then inside write next batch, we've got a writer which we can just store multiple Gimbal packets into. And as soon as this function returns, all the Gimbal packets we stored in that buffer get sent in one or more UDP packets. And then the microcontroller spews those UDP packets out over the serial port, and then the Gimbal firmware listens to them. I have not seen the Gimbal crash since I decreased this max packets per read batch constant. So hopefully we're doing all right there. So I don't know if it's worth having a confirmation for arbitrary packets going through. But here are the writes. Here's where we actually queue the write. Let's confirm the write. So that would be controller.send and then a message with the timestamp. So what kind of message do we want? I think this should be another type of Gimbal value. Maybe I just split that command up into a Gimbal value read and Gimbal value write. But I feel like there are a lot of cases on the client where we would just want the latest version of this value regardless of who set it. So that would be a reason to include that in a different data structure that I could just keep with the data. And this Gimbal value data, I think, is just the address and the uint16 that goes, or the int16 that goes with it. But let's open that up too. That's over here. Yeah. I'm debating the merits of having a different enum type that goes in here versus having... I think I want an enum type. I feel like that should probably just be a different message type. Do I even care? I think it would be really nice to know if I'm writing to it or not. Is there already some concept in Rust about read versus write? I'm sure there is, but it wouldn't have all the serializations that I need. I'm also just thinking about how this would show up in JSON serialization. I mean, this will turn into a list. It'll be weird. This will be .0. This will be... Yeah, I don't know. Value op. I'm also getting really annoyed with all of these data structures being in other files. I think I'm going to really try to limit the number of dependencies message.rs has. Like, I want this file on its own pretty much to define the message format. Like, config is fine, because that also is fairly external, but like, this stuff annoys me. I mean, importing Gimbal packet kind of makes sense, because that has a bunch of functions on it that are important. Like, importing Gimbal packet kind of makes sense here, but I'd like to curtail the rest of this if I can. All of that stuff should be part of the message format. Drag, gimbal value address, data, request scope. That seems a lot nicer. Okay, let's come back to control status and just implement this part, gimbal value op, in the gimbal value message. So that's only sent around here. Oh no, right in polar. Oh, that is actually all stuff I wanted. I think message and vecmath are both safe to do glob imports with. Oh, this is the message data type, not the message. Right. Gimbal value op. Read complete. Just gonna put this timestamp on a different line because this is getting a little too long for my taste. Okay, and now we want to send a write confirmation. This will be a write complete. That is nicer. Those little gimbal structures were much more about the message protocol than about the actual gimbal controller. All right, more plumbing. Where is my controller? Self.controller. Cool. Okay, this can store the value regardless of its source, I think. I don't think we care about that quite yet on this side of it, but we'll use it on the debug tools probably. And this was some incomplete code that I think I want to comment out. Actually, it might be easier to finish it than comment it out. I say finish, I mean just add this much. There's a lot more to do there. Whoops, that's not what I wanted. Undo. This is... Oh geez, did we just get us... Oh, why did that happen? Oh, now the Twitch stream... Is Twitch coming back? I think Twitch is trying to come back. Oh man, sorry about that. Twitch is playing me an ad right now. Oh, sorry about the stream hiccups today. Isn't compiling fun? I think compiling might require more T. So the idea here is that the Gimbal control status structure here just has a dump of a bunch of stuff that's going on inside the Gimbal control loop that would be useful to know about externally. So for example, the stuff that's actually on the screen in the stream, the angles and rates here, those actually aren't represented in the WebSocket protocol yet, and so this is something I want to add, and so it'll be part of this other structure. That'll also be useful for example, the PID loop's internal state. Some of the stuff you will be able to see it in the Gimbal's parameter space. For example, the control rates will be there now that we support writes as well, but well, I need to make the corresponding change in the web front end, because the web front end is going to be broken right now. Like that. Exactly like that, actually. Can we get tracking back? Yeah. Let's just fix that. So this changed. This is now gimbal value 0.adder. I think that's enough to get it stored in the model correctly. So now we have this enum value. So Gimbal value is now a list which has this object that has the adder and value, and then this string says read complete. So these two values came back from a read. These two values also came back from a read, and they come back pretty infrequently. And what about our writes? Oh, here's the writes. They're up at the beginning. Great, so these are our control rates going out, so you should be able to see these move if I move the gimbal. There's the yaw axis going to 50, then to minus 50, and picking up automatic control. Great. And these are also just continuously updating. So then the gimbal list page is also going to be broken. Yeah, these are not rendering, so that needs fixing. Oh man, I've got to use the restroom, and I might as well refill my tea. I will leave you with the cat cam for just a second. Oh yeah, Ryan's pointing out that all of this is running on the same machine I'm compiling on. So yeah. Also, some of you have pointed out audio interference. If you can mention what kind it is, because sometimes there's just like analog interference, but if it's like dropping frames, then that'll sound like clicks or something, and that just might be CPU load. I don't usually run demos and compiles on the same machine that I run OBS on, but since this project involves developing the streaming infrastructure, that's where I am. I'll be right back. What a good cat. Alright, so we just need the gimbal value right here. And then, what did we call this? The op. Read complete or write complete. Maybe I can turn that into a CSS style. give those better names. MC string's fine. Or maybe unknown. This will be for values that are unread. Because it has a value, we just haven't read it yet. I have all this stuff just to compute this one stupid style, which seems a little silly. I was just already using this library elsewhere, React CSS. As using it in a trivial way here seemed less silly. Now they're all broken. Missing key. Where? Oh, right, class name. That was the problem. I'm not sure where this key warning's coming from. Oh, what am I iterating over? That could be that. Maybe it wants a key on all the sub items here too, not just the outer item. Oh, these are not the outer items, these are the inner items. Maybe this is where it wants the key. Oh, right. There's a new kind of string interpolation I could be using for this, right? Yeah. Is that parens? No, squigglies. Yeah. That's better. That seems earlier in this whole process. Is that only on this page? Also I'm tired of all this key stuff that I added for debugging an earlier problem. Let me fix that. Goodbye, node modules. Okay, the stuff in this tab is about the vision subsystem. So very roughly, the output of this is the tracking rectangle. So the manual control stuff is here too. But then Gimbal, the idea here is that the actual tracking feedback loops, those parameters will go here. So right now I have one gain, then there's a bunch of rectangles that are in the config file but aren't actually here yet, that's kind of annoying. And then the limiters. So I'm going to be replacing all these with probably proportional and integral gains. I don't know if it's worth using derivative for this particular one. Nice. Elman suggests for an Easter egg on Halloween, the tracking software should randomly track a dark area and label it Ghost Monster or something like that. Yeah, that's spooky. Okay, well, if all this stuff that we just changed works, we should get the writes as well as the reads to the gimbal showing up on the message bus where we can see them on the web client. And that'll be nice. We still won't actually have the internal gimbal state. I added a little bit of that, but oh, this is getting choppy. This is using all my RAM and then some. Let's stop recording from the stream at least. It's one fewer thing to use all my RAM on. This is honestly probably fine until I get the new control loop, or the new tracker PID loop running. So this actually might be a good starting point for adding graphs and stuff where we can actually show these, because I think I do want both of these values, the angles and the rates. So maybe we just add these to the web interface now. Alright, so we have gimbal values. We're also going to have a higher level object called gimbal status. Maybe gimbal control. Controller. Control status. Okay, gimbal status. See, these just save the entire message, including the headers with timestamps and stuff. So there's a lot of unwrapping on the client side, but then you get access to all the data there. Yay. Crunch, crunch, crunch. Do the compile. We are currently guest. Why is that not a... oh, that would be why. There we go. Ooh, typo. It thinks there's a memory leak. No, I just have a lot of events attached to that one. These are still not rendering. I think 4C is one that does have a value, for example. They're here in the model. Can I just set the breakpoint, use some modern JavaScript debugger features or something? I think that stuff's actually been working pretty well. Gimbal value. So we're paused here. There's the message. We've updated index list. We should hit this line anytime the Gimbal page tries to render a value that does exist. I was still paused. That looks right. Op is read complete. There's the model. This dot set state. Where are some values I'm definitely writing to? Not there. Three. That's easy to find. Oh, here we are. Operate complete. Why don't we have any contents? Oh, I forgot to change this. This is now called value. I'm not even sure how I want to format this. Yay, much better. This should have the same kind of freshness display where it fades as the value gets older. Like these. You kind of see them flashing every time they're requested. Oh, Harrier Pigeon asks what I'm doing right now. That's a good question. I'm mostly just adding more Gimbal debug features while I was waiting for a different compile. And the compile finished, so I can do other things, but I'm adding a thing so that when I send values out to the Gimbal, they also show up here, not just when I finish reading values. I'm about to add some CSS so that I can distinguish the two. Maybe not even CSS. Maybe I actually, now that I just added the CSS, now I'm thinking, oh, maybe I want like a little R or a little W. Maybe the CSS is the right option. I think maybe just a border color around stuff that I've been writing. So I've got these little substyles. There's Gimbal param, and then op unread, or op write complete, or read complete. gonna try like a light, like a very translucent blue border for reads, and kind of like a more opaque orange border for writes. That is unreadable. Oh no, there's a border. I actually wanted that class to be on the parent, not on the actual span. Can I just do that? Like, this should just be about the text and the opacity. I think this, I can just stuff both of those classes in there. Let's take a closer look at that. Maybe background colors are more visible for this. Right, that's being overridden already. Let's just do that way. Oh, right, I think that's background color is what I want. I don't really know how to internet. No? Oh, I missed a... No, I think it was background. I just missed a number here, right? Yeah. Forgot a 0. Oh no, it was background color. Maybe it was both problems. And I think background is also a thing, but background color is more specific. Can it not render a background because this is a span? Is that what's going on? What if this was foreground? No? Do these have to be floating point? Maybe I'm just forgetting how this CSS construct works. Oh, the first three are integers. That's better. Yay. That's pretty much what I wanted. The colors are a little arbitrary, but I've got control rates for the gimbal. Cool. We could actually start graphing some of this stuff, but I would rather use the cooked values that are coming out of the control loop rather than just these internal memory values. So let's keep going. I should already have those in the model. That's gimbal state or status. Here it is, gimbal status. I just added this. It's currently empty because I think we need to actually send those packets still. Oh yeah, Rust probably gave me a warning about ignoring this object. No? I thought gimbal tick returned this structure that we just added. I must have just not saved this before I compiled it. This is the code that should be breaking it and should be adding some new functionality. So tick, this is the main gimbal control loop tick. We have the config file, the gimbal port, the last known tracked region. Then the output from this is actually some messages that go out to the gimbal, as well as this control status structure. The control status structure just exists to inform the other parts of the system what's going on. This is also currently responsible for storing a debug string. I think I'm going to remove that too. Alright, so gimbal.tick. I think that should return an option, right? Because this has two paths. It has like a I'm not doing anything with the gimbal path, and then it has I guess my question is, if the gimbal is not fully responding, or if it's halted or something, do we want no control status packets, or do we want control status packets with rates set to 0? I think maybe the answer is the latter. Maybe this always returns a gimbal control status. And then state, which is the module that owns this, should actually probably save that so it can use it for like debug overlays. And then the question is what to do with it when we're first starting up. I think we do actually want this to be an option. That means it can be none when we start out. Then we always update self.gimbal status. And then we can also send out a message right here. Do we have self.broadcast? Oh, right. Right. Controller state actually can't send messages. So we could either give that a getter, or we could just make that public. A couple of these members are public already. Alright. Add that debug code back in. Let's just pretty print this whole structure. Not even pretty print, I guess, just regular print. I was thinking about taking that gimbal object and pulling it out of state, because it's starting to need maybe a tighter coupling to the message layer. Do we have much interaction between it and state currently? It's gonna want this gimbal status stuff though, like especially right here. It's also possible maybe we want to move this out of the module, the drawing. I think I want to pull the gimbal controller out of this file. I don't think it's doing any good here. And let's move it up a level. Drawing really does need to be split up. I've also got these two things called Gimbal now, the controller itself and then the port that I use to access the outputs. Can the controller own the port? Because I'm just borrowing it, right? No, I get a copy of it to keep. but only after start, which is part of the problem here. And so we're passing this to handle message because some controller messages result in Gimbal messages. And then we're passing it to every tick because that's where we run the Gimbal tick loop. Making a mess here, trying to make this cleaner. Some of these go directly to the gimbal port. This makes a little more sense. So we have a module called Gimbal here also if we didn't need enough overloading. We don't actually have that in the local namespace, I think. How does a weird noise coming from the heater? That seems better. This doesn't even need to know about the gimbal. This is going to immediately make it hard to do drawing, so I'm probably going to have to refactor drawing too in the same change. Oh, and this wants the tracking rectangle. Tracking region should be public, I think. Let's just take that out for now. Nope, this needs the gimbal too. Oh, actually, I want to take this code out too. This is drawing the gimbal's gain regions, and this is all on its way out, so let's not worry about that. Okay, no more references to gimbal in this file. Great. And so this file is also probably on its way out. Like, everything in here is somewhat badly categorized and probably needs to go into a different module as soon as that's feasible. For example, there's a whole object for manual controls. This maybe could go with the manual controls instead of with the state. Yeah. So drawing is going to be missing some state, but I think I'm going to get it back in the web interface really soon. So let's see if this compiles. I think we might have everything we need for now. Three Tucos on the screen. I'm happy about that. It's drifting though. You know, actually, even when we are intending to keep the gyro still, it might make sense to send it our last, or keep the gimbal still, it might make sense to send it our last like gyro rate drift compensation estimate. So that even in halt mode, it tries to kind of use its last estimate of gyro drift to stay still. Oh man, I have to use the restroom, and this doesn't compile. Oh well, I'll be right back. He's still kind of in frame. The tracker can't get distracted when the tracker isn't connected to the gimbal. Oh, this is messy. Giving it the tracked region. I should really be saving that. control status, not controller status. Let's go ahead and save that gimbal status. Some of these have reasons to be out of line, but let's make more of these in line. I think I just wanted these all to be the same style, but it was not really working out for me. Bunch of that stuff wants local config. Oh yeah. Those objects have non-trivial dependencies. Whatever. How about the rest? Yeah, field was never used, that's fine. Oh, wow. I didn't even have to do that, it just did that automatically. That's cool. I think the rectangle was already over there, and it was enough to push the gimbal the rest of the way. Okay, so now are we getting stuff in the model? Gimbal status. There it is, gimbal status. Timestamp, message, angles, rates. Cool. Let's graph that stuff. So we have motor control, tracking, firmware parameters. Let's add up here control status. gimbal controller status, maybe. And in that we have encoder angles. Okay, let's figure out where these are and then refactor a little bit. So it's model.gimbal status, message, and it's gimbal control status. Dot angles. So in this case, I don't have a separate trigger, so I think I'm going to use the timestamp as a trigger. The trigger is just a part of the model where it doesn't consider the value to have changed unless the trigger also changes. So usually I have that reading some kind of counter that came in per packet. But in this case, I should just assume all these values are valid when the packet comes in. Which isn't strictly true if, if I wanted to just have the graph not update when no data was coming back from the gyro, then that might be a case for having a separate counter in here, but I think right now I can avoid that. So I think I just want to use the message timestamps for both of these. I can even make a little variable for that. Alright, got a series, let's add a second series. Right now they'll be the same color. This is what I was doing before, kind of for some RGB sort of coloration. In this case, there's no G, there's just red and blue if I have yaw and pitch. So that should display the encoder angles from the gimbal. And we can do something very similar to get the controlled rates. Let's see if that worked. Unexpected, what's it? Oh right, .0 is not actually JavaScript syntax. That would be valid either in Rust or in something that before I just decided to make all these lambdas, I actually had a little string that it would parse. But then I just decided to make them all lambdas. And so now it's just JavaScript syntax. Sweet, so it's putting X and Y on the same graphs, which may or may not turn out to be a good idea, but this might be more useful than just having the text in the corner of the screen. So if this is in the middle of the screen, then the control rates should both settle down to 0. But then you can see it kind of bouncing up against the side where the control rates are decidedly non-zero again. Nodding up and down. Yeah, maybe separate graphs for the angles, but then one graph for the rates. Yaw angle. I really like these chart tags. It's like one of those things where you implement it and it takes a while to make it work, but then it's really convenient afterwards. There we go, yaw angle, yaw and pitch rate control. This is the smoothest pulling of the angles I've ever had on this gimbal, because the debug code I ran before was not this fast. This is just trying to use all the bandwidth it can without crashing the gimbal firmware. Oh, this is delightful. Yeah, let's check this in. This is a bunch of refactoring, but then we can at least have a nice change to show for it all. Oh, this is so good. I don't want to cover anything up. Alright, this is converging on something I'm happier with. Remove some of the overlay debugging stuff. I've currently made it a little harder to get debug information from the gimbal controller all the way over to the text overlay. But I think I'm going to change how the overlay drawing is partitioned in the controller soon. Make it some higher level module that can just reach in and grab the data it needs temporarily without holding a reference to anything. Celebrate with some tea. That's great. There's already a good deal of noise in the rate control, but one thing I was thinking about was, especially if I want to compensate for very slow gyro drift, the integers that I'm outputting actually kind of have less resolution than I'd like. It might be worth adding plus or minus 0.5 of noise to these before outputting them, basically dithering them, so that if I have some small signal which would actually get eaten by the quantization, then the dithering will actually help it stand out by intentionally raising the noise floor above that least significant bit. And for something like the velocity control, like this is then getting integrated by the firmware at a higher precision, so Like, I don't think the actual randomness will be noticeable. I think it'll just allow it to stay centered without having to just... I mean, if it was a closed loop thing, I wouldn't have to worry about that, but the drift control isn't necessarily a closed loop thing. It might have to be open loop, or at least open loop in the short term and closed loop in the long term. See, you could actually mine this data right now for some good drift compensation values to use. Since if you assume Tuco is staying put and the tracking is on average holding the same location, then you can take a long-term average of these and compensate for drift. So I think part of this is going to be identifying like when it can feed that filter and feeding the data into the filter then. These outputs are actually kind of interesting to watch now. I'm also planning on having, in that same data structure we just added, information about where the contributions to the rate control are coming from. Because this is just the integer vector we're giving to the gimbal, but I think fundamentally it's going to be something we create by adding together a bunch of floating point vectors and then doing maybe some quantization or some dithering before quantizing it. And so all those different contributions would make interesting graphs too. There's going to be the drift control and then multiple sources of gains. I think the ones that will be useful to separate out at this level are the proportional and the integral gains. All right, to-do list. Where's our to-do list? Got these .untilde files. Oh, is this for Unicode? Let's delete these. All right, we got status reporting and gimbal state graphs. I'm going to put motor control at the top. Actually, I wonder if those should go on this page. I think maybe just the top of the gimbal page. This is much better. I like having these writes visible. Oh, we also removed a big ol' section of drawing functionality with those gain rectangles. Let's also clean up the associated bits of configuration detritus that are left over from it. That would be gimbal tracking rect color and sensitivity. Neither of those are needed. It's slightly convenient that control seeing that actually closes the browser window that it opened. That's neat. much do I care about that gimbal status? If I did want that to be in the debug display, how would I do that? I mean, there's the easy way and then there's the correctish way. Alright, well, I think maybe it's time for the new gain system. This might also be a good stopping point to end the stream. There's a new gain system. There's maybe doing more debug text, since I kind of liked having the gimbal debugging up here. Oh, I could just do that at this level. Maybe I just want a bunch of functions in like a drawing module that aren't even part of the objects, but they just know how to draw stuff about those objects. I have this overlay.rs down here, which knows about just generally how to draw stuff. But I think I want like a corresponding file up here that knows how to draw specific objects that the controller has. See, these two clauses are about the computer vision subsystem. This one's about detecting objects. This one's about the tracked rectangle. This stuff does not even reference the current object. Maybe it wants to move out. And maybe we call this draw tracking overlay. Okay, I'll split this in a few different pieces. We can further split this later. And this doesn't even need references to that stuff if we're in the local object. just seems opulent to have mutable access to all of that stuff. Gimbal status, yeah. Does it even build? Nope. Gotta sprinkle some semicolons. Missing my vector math. And controller mode. Oh, that's from config. Whoa, now the gimbal is very drifting. Pitch drift is real, folks. Okay, and now we have none. Why do we have none? So that's supposed to be self.gimbal status. Oh, this should be self.gimbal status, not a local variable gimbal status. Actually, maybe I want both. Nice. Now it's pretty obvious I'm programming in Rust, because you can see, I mean, nobody else would write this like this. The debug info is nice. I might actually put that all on the same line. I wonder if there's a format specifier for options that replaces the none case with something else. Because it'd actually be nice to just have that not be there when it's none and to not have it say some explicitly. But for example, if I just had it replace that with an empty string, like I would need to do that after formatting. I don't think I care that much. It's just debug text. Huh. It says it's running. I think that's interesting. I think my OBS lost its connection. WebSocket exception invalid state. Authentication failed, closing connection. So this has some, there's a state it can get into when I reset the Rust server where it connects to the new server using the old key and it gets an authentication failure. So it looks like that's what happened here. And then it closes the connection and tries again. But it looks like then it got stuck in some other state with an exception and now it's just not restarting. That's a bug to look into later. Now it's working. Now the debug information is more compact, which I like. It's also a little bit hard to read with that low contrast color scheme. Whoa. That crashes as soon as I scroll down to the color picker that doesn't exist. Cool. Let's fix that. It's that other config thing that I removed. I was going to remove the editor for it too. That's what this is. It's this stuff. Let's try the status rectangle. Yep, that works. Halted. Manual flyer. Yeah. Great. This will be another good time for a check-in. What's next? I feel like I could end the stream right now. Or I can always just keep going. Oh, there's kind of a big piece that's next, which is kind of one of the things I really wanted to get to on this stream, but I was like 3 and almost 4 hours in and I haven't started it, which is the new gain system. Proportional and integral controls. I think it might be time to take a break from streaming and do some of that work off camera. I've got a reasonably good idea of how it's going to work, but I think the combination of being a little on the tired side and not having a really clear plan means it might be a little boring to continue. So I can see a few different representations to use for this. The current gain rectangle thing uses rectangles, and it's not that convenient because the thing that I actually want to edit, it turns out, I think the most sensible way of doing that is for each gain set to have a width of the region that you're talking about, and then they're always just like one-dimensional cuts. So you have one list of horizontal gains, one list of vertical gains, and I think they're also always symmetric around 0. So you have one list that says if your object touches a line that's like x units away from the axis, the center axis in the horizontal direction, then as soon as it gets to that line, any further movement is going to start influencing the movement of the gimbal. And then so you start seeing that affect the proportional, affect the control via the proportional gain, and then you also see it affect the integral via the integral gain. Oh. Yeah, so I think maybe this is a good wrap-up point for the moment. I think right now I might have the energy to work on this more than I have the energy to talk about it. I mean, I could make it a quiet stream where I don't really feel the need to talk about what I'm doing continuously, but then I feel like there's less of a point. I'm happy with the correlation tracker at the moment, though. I mean, it could be better. Maybe I lied. Maybe I'm not actually happy with the correlation tracker. I mean, let's play with the correlation tracker a bit. Oops, sorry. Oh yeah, now it just wants to track me. So I mean, if I move quickly while also trying to make an effort to have the same pixels, then it seems to do alright. But if I change significantly, then it loses me pretty easily. I get to track a better object. See, this is not a very unique object. Correlation isn't going to help it that much. Maybe this controller. Yeah, it feels like it just doesn't have a very good lock on that. It'd be really cool, actually, to get some visualization of the template object it's looking for and how that changes over time. I don't know if that's in an easily visualized space. But that would certainly be interesting to look at. So that's not a reset. That's like, it's actually just, that rectangle that's kind of far away is its best guess about where my original rectangle went. If it was resetting that age counter, which you can barely see, but if I put my arm under it, you can kind of see it. That age would reset to 0 if it was actually resetting the tracking, like that. That should have reset the age. Maybe I need the debug to be a little bit less transparent. Oh man, the white on black text looks so much better now that there isn't a terrible alpha blending bug. Yeah, now maybe you can read that a little better. So the age just counts up in frames, 1 frame per continuation of the original tracking. And so if it resets the tracking to a new template image, that goes back to 0. If I move it around manually, then it should just stay at 0. Well, it doesn't even render that when I'm in manual mode, but if it did, it would be at 0. Yeah. Alright, I mean, the correlation tracker's okay. I think it's good enough that I don't think this is the bottleneck right now. I think when this is having trouble tracking Tuco quickly, the problem is way more about the gimbal gains than about the correlation tracker now. Yeah, I feel like that too. Nick says, I'm thoroughly inspired to build a computer vision project now. Last time I played with this stuff in any capacity, around 2007, it wasn't nearly this reliable. Yeah, right. I played with this stuff before this project in, yeah, like the early 2000s, like 2002 or 3 or so. And I remember having a lot of fun with OpenCV and the camshift tracker and, well, I guess more recently. So a few years ago, I made something that had to be pretty low computation power. So it was running on a Odroid, which is kind of like a Raspberry Pi 3, but it was before those were out. And it was doing some computer vision, and I ended up using sparse Lucas Canard optical flow for that one. But this is just so much more CPU power available on a desktop, and so like this correlation tracker, I don't think you'd get this running on a Raspberry Pi, even if it doesn't need the GPU, but it's still pretty nice. This is all still that correlation. Oh no, it did a reset just then. But when I started the sentence, it was still the correlation tracker. I'm trying to distract it using this paper. I can totally distract it. Yeah. Let's at least check in that more readable label chains. Nick says that has potential as a game mechanic. Yeah, right. So I had some code in here where the age would reset if the PSR was very low or if the area was out of range, but I removed that earlier on the stream. So right now it should only reset if if manual mode or the computer vision object detector tells it to. So if you see it reset and I haven't been touching the manual controls, it was probably a very short-lived object detection. There's no like temporal coherence filtering on that yet. There might be in the future, but right now it didn't seem like the thing to do. If I cover up Tuco enough that it's no longer detecting him as a cat, then I can steal the detector. But as soon as I uncover him enough that he's detected as a cat, then it goes back. And you'll also notice maybe that this time when I'm tracking, the rectangle never changes size. And that's because I'm not running the scale estimator right now, because that was really CPU intensive and it was causing it to run slower than my frame rate. And now it's actually running faster enough than my frame rate that it seems to pretty reliably get all the frames. Cat force too strong, yeah. Alright, well I think I'm going to wrap this up. I'll probably do some more coding off stream, so maybe I'll have some more of that to report later. Also, just a reminder, in case you missed this earlier, I've actually got a stream scheduled tomorrow. Usually you might know I don't schedule these things. But if you just search for me on YouTube, you should actually see one scheduled. Yep, IntelliKeys Teardown and Modernization, live with ATMakers. So that is actually something where Bill from ATMakers and I are going to get on Google Hangouts and try to do a stream together where we both tear down this object and talk about how it works and how we can modernize it so that people can keep using it. So we just unboxed one earlier on this stream, so if you missed it, you can catch it in the archive once that's live. And it's like a big reprogrammable touchscreen keyboard that is intended for assistive technology uses. So, you know, if you have various mobility or developmental or, you know, injuries, then like anything where you can't use a normal keyboard, there are some overlays that actually let you use this kind of touchscreen keyboard in a lot of different ways, and then it controls software running on a regular desktop. And the problem with it is that it's actually kind of old at this point, and the original manufacturer is no longer supporting it, but a lot of people still use these devices. So this project with Bill is something where we are looking for ways of either at the driver level or the firmware level making some changes to this device to extend its life without having to modify the hardware. So yeah, I'm looking forward to that too. And hopefully some of you might find yourself there. If not, there will be video archives so that we can all tune in later. And with that, I think I'm going to sign off for the moment. Thanks so much for stopping by, and thanks for hanging out with me and Tuco and my robotic cat thing. And if you like the show, if you don't like the show, if you want to see some stuff, if you have suggestions, you know, feel free to let me know. There's Twitter, there's DMs, there's YouTube comments, there's Patreon. And a special thanks to anyone who supports the stream on Patreon. It's really special to be able to spend so much time doing this, and it's all because of people like you who just send in, you know, as little as just $1 a month helps way much. Just being able to help me reliably pay the rent here, and or at least pay some of the rent with just being able to do this work. So it's really great, and I appreciate it a lot. So we'll sign off, and I'll see you folks later, tomorrow in fact, if not sooner. I mean, there's always the possibility I decide to do some crazy late night stream, but usually it's been one stream a day lately. So I'll probably see you folks tomorrow morning. I'll see you next time. Later.